So in this class we have been talking about histograms, and I want to show you some of the pictures that I gave to you in class. If you'll notice here, it says what's wrong with the histogram on the right. A histogram is a graph that connects the bars because you're dealing with intervals here. And if you look at this histogram on the right, it would appear that the time between eruptions doesn't seem very significant just because of the scale that they used along here on the y-axis. It can be very misleading here. But when you look at the scale a little bit more broken down, you can actually get a better depiction of how much time has passed and the number between the eruptions times per group. And so if you look at this, sometimes what you have to watch out for when you're doing a histogram is to make sure that your bin sizes are appropriate and that they would contain enough data to give you a good picture. But also you want to make sure that your frequency or your intervals that you're using here to represent your frequency don't make the person who's viewing the graph think that it's more significant or less significant because of the scale factor that you chose to use. So what we're looking at here is just a basic histogram. Now, the thing behind histograms is each graph tells you a different story. And histograms kind of give you that general idea of the shape and the spread of data, but they're not so good for finding things like what's the mean. Why is that? Well, technically speaking, to find the mean, you're going to add up all the numbers and divide by how many there are. But the thing is that if you look at this histogram, we've got ourselves some intervals. And it's very difficult to find the mean of something if you're just dealing with intervals. So sure, you can look at this and say, yeah, there's about 20 of this particular bar graph right here. However, 20 of what? Well, it's an interval here, so it means that there's a set of numbers that there's 20 of. So when you're looking to do application with the histograms, not necessarily you're going to use it to find a specific mean. The median, you can get a general estimate of. Again, it's going to be an interval. It's not going to be an actual number. So you can still kind of figure out where the middle of the graph is. And if you do that, you kind of want to just estimate as you're going through here and you say, okay, those two bars are about the same, and then it leads into this much of this one. So we have about this here, which looks like this would bring these two even. And so you're kind of judging this and saying, okay, so I have this much here, so this much goes from that. And then that probably would finish up this bar. And then you would say, all right, then the next bar is right here, plus a little bit more would be here. And so you're actually just kind of estimating the height of each of these bars so that you can actually get started and closer to the median. So I'm going to finish this up here. We got about here, and then you're going to go here. Got the rest of that bar. So then we're here. So somewhere within this region right here is where our median would be. So you have to kind of estimate. You can even draw on your graph to figure out the median is, but then it would be the range. So you've got a range of numbers that the median would actually be between. But then we can talk about the shape. Now the shape kind of does this thing, which you guys have learned means bimodal. Is it symmetrical? By no means. Are there gaps? No. Is there an outlier? Not really. Can you talk about skewness? No, because this is not skewed, it's bimodal. So it gives you the general overlook that says, okay, within the first set of time from here to here, its time, or the highest amount of time between eruptions per group would be right about here, and then it dips between these intervals, and then it goes back up. So a lot of the histograms is really just interpreting the data. And variation, again, you would not use an interquartile range of this. That's much more appropriate for box plots. Would you use range? Sure, you could use range where you're taking somewhere here, like maybe this is 98 minus, this would probably be here, not 0. If this is 45, it's probably like 43. So you could find the range of this data by subtracting these numbers. Again, it's going to be an estimate. Would you do MAD, the mean absolute deviation? Well, if we couldn't really find a good mean, there's no way we're going to be able to do MAD as well. So again, the big thing behind histograms is that you should be able to interpret them, and they give you a good picture of the overall trend of data. So this one right here is just a basic question on how to create a histogram. When you create a histogram, you're going to want to create first a frequency table. Frequency table helps you decide what your bars are going to be. Now, you also need some bins. That means what numbers will collectively go within here so that you can start using your tally marks. So you kind of look at your data. I've got 10, for everything smaller than 10. I have a 9. Looks like that's the smallest number. And then you look for your highest number, which is 50 here. So we're really going from about 10 to 50. So you want to say what's a good set of intervals to do. Well, I would either do about 10 units in a bin or 5 units in a bin. So I'm actually going to do 5. We're going to go from 5 to 9. And then we would be 10 to 14. And we're going to have 15 to 19. And we're going to have 20 to 24. 25 to 29. 30 to 34. And we're going to have 35 to 39. And we're going to have 40 to 44. 45 to 49. And then 50 to 54. And count your bins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now there's 10 bins. Let's look how much data we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I'm looking at this, I have 21 points here, which means that these bins are pretty separated. So then you would sit there and you'd question, is this really the good bin size to use? Because if I have 20 data points, 10 of these, that means on average they might give me 2 each. This would result in what we call a misleading graph. So maybe it's better to go ahead and do our bin sizes of 10. Frequency. So again, we're going to create our bins. So this time I'm going to actually do from 0 to 9, from 10 to 19, from 20 to 29, from 30 to 39, from 40 to 49, and then from 50 to 59. And that's a little bit better. 6 bins is good. So now you just go through here and you say, with tally marks, I got one of those, and 12 goes in here, 14 goes in here, 15 goes in here, 16 goes in here, 18, oops, that was 5. 18 goes in here, 22, 25, 23, 21, 20, 20. Then we have 18, 14, 16, 19, 11, a lot in here. Then we have 9, 15, 28, and 50. So look at our overall data here. Most of the data is within here, which is going to give us a pretty high set of bars. Some of y'all may have opted to have called this one an outlier, which technically it is, and you wanted to get a closer look in here, so then you could have used these bin sizes. So a lot of doing it with our histograms is just kind of getting used to how to pick your bin, because I think that's the toughest part. We're going to start here from 0 to 9, and I should put it there. Usually when you start a different number other than 0, you're going to put a mark here. So we have from 0 to, and actually I'm going to put there, 0 to 9, which means this next tick mark would be 10, which means our next tick mark would be 20, 30, 40, and 50. And then our frequency, we're going up as much as 12, so we need 12 at least. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. It's 2, 4, 6, 8, 10, 12, 14. So this is frequency. And these are our bins. If you knew what this represented, like ages or something like that, you could call that on the x-axis here. Alright, so for our first bin, from 0 to 9, we had just 1. Our second one, we had 12. Our third one, we had 7. And then way out here, way out here we have this. This is going to be what we call an outlier because it's just removed from the graph. It looks like it could just be a gap where there's just one. But again, if you look at your overall picture here, and if we recreated the histogram to be better representative of what's going on in here, you probably would count by 5s. And that would give us a better idea of the overall histogram. So what you'll do when you're dealing with a histogram is first off, choose your bin size. Alright, this was too much data for the bins here. However, because of that one outlier, this could have been a good one to have used. Because then it would give me a little bit better of a picture of what's going on within here where we have so much data. But remember, once you get to higher numbers of data, like, I don't know, 150, you're going to get a better picture. And so the bin sizes, you need to just make a judgment call of what you think is appropriate. If you've only got 1 or 2 numbers per bin, you're not going to get an accurate picture. If you lump them up too much, kind of like this, you're almost getting a misleading picture because what's going on in here where the majority of the data is? This looks like it's actually skewed to the right, but what's really going on in here? You might want to decrease your bin size to get a better picture.